Hello everyone! In this video, we will work on part 3 of data visualization. First of all, let me create a new R script. And this is our third video in data visualization, so I'm calling it data visualization part 3. And the topics we are going to cover are called bar plot, variations of bar plot, and then box plot, and then we may talk about the basic grammars of using ggplot2 so that you can create your customized graphic tools to visualize your data. So first of all, let's start with bar plot. And if you haven't installed ggplot2, you may want to type install.packages ggplot2. And if you have installed it, you don't need to run that line. You just need to run library of ggplot2 so that your ggplot2 package is loaded and you are able to use the functions, the datasets within that package. And in this video, we are going to work on two datasets. One is called MPG, and the other one is called diamonds. So these two datasets are all built-in datasets within ggplot2. So once you run the library function on ggplot2, you are able to use these two datasets directly. If you want to learn what is the diamonds data, so you can run question mark on the diamonds and you're able to see how many data records this data set has and how many variables it has. So it has price, carat, cut, color, clarity, so everything around the diamonds. And the first graph I want to check is that which cut has the most observations, which cut has the least. So if you look at cut variable here, it is the quality of cut. There are actually 5 categories in this variable. So let's check, let's draw a bar plot on this cut variable. My first question here is which cut quality has the most observations, or which has the least, right? If we draw a bar plot, it should show us like the bars, like which one has the highest number of observations, then the bar will be the highest. Which quality of cut has the lowest number of observations, then the bar will be the shortest. So let's use ggplot and specify the datasets, and then we want to assign the AES, but this time let's try to put the AES within the GEOM bar. So I have mentioned before, you can either put the aesthetic information within the ggplot function, or you add that information within specific geometric objects. So let's do the AES here this time, and I'm going to let x equals cut. So that means I'm going to draw a bar plot according to cut variable. And if you click to run these two lines, you are able to see the bar plot like this. So you can see the x variable is the quality of cut, and the y variable is the count, which means how many observations you have for each quality of cut. And we can clearly see ideal has the most, fair has the least. So maybe you want to change the graph, right? You may want to flip the graph, like showing the bars in the horizontal way. So if you want to do that, you can define this graph as P1, and then you can do P1 plus coordinate. So we are going to do coord flip, so which will flip the bars into the horizontal bars. First of all, you need to run these two lines so that your P1 object is defined. And then you can run the P1 plus coord flip, and then that graph, that bar plot is flipped. If you want to know how to draw these bars, if you want to know how these bars are drawn, one thing you can do is to run the table function on the dataset and then the cut variable. So table function will help you generate a frequency table, and that table will show you exactly how many observations you have for each cut of quality. Here I run the table function and I'm seeing fair has 1,610, ideal has more than 21,000. So this bar plot on the right side was drawn according to the frequency table here. Like based on how many observations they have, they just draw the bar according to the x-axis, the count here. So on this side, on this graph, they are drawing the bars according to the y-axis. So you can see ideal is a little bit over 20,000, and this is the y value with about 20,000. Let me type the second question here. A bar plot with percentages. And I'm going to copy these two lines here without naming it to be P1. And what I'm going to do is that I'm going to add a y here, and I let it equals stat proportion, PROP. And after that, I'm going to set up the group equals 1. So this setup here is that I'm going to draw a bar plot here, and I'm going to draw the bar plot according to the cut, that variable. And the values I'm using are the proportion numbers. And I set group equals 1 so that the proportion numbers are the exact proportion relative to the other types in this variable. So which means the proportion for ideal will be 21,551 over no matter how many observations you have in the whole data set. So I can run these two lines. So just to remember, when we add these two information, they are within the aesthetic parentheses. So these are also aesthetic settings. So here is the graph. You can see ideal has about 40% of observations, and fair has about only 2.5 because that's about 5%. So it has about 2.5%. And sometimes you may want to color the bars, right? You may want to draw a much more beautiful graph with some beautiful colors. So how to color the bars? One thing we can try is to copy, let's use the original graph we draw here. It should be the same, but this is easier. So I have as x equals cut, right? Here, I'm going to set up the fill equals cut as well. And let's see what happens. Okay, so this is the graph after I add the fill equals cut. So you can see I have some information here showing which type, which quality of cut is using what color. And so you can see those colors are matched to the graph, and it's kind of beautiful, very colorful. Another thing you may try, which is not a good thing to do, but you can also try to use color equals cut, because when we talk about the color, the bars, you may want to specify the color. So if you spy the color equals cut, it will look like this. I don't really like this graph because this color equals cut option only colored the outlines of the rectangles. But when you set up fill equals cut, it really colored the bars. So it's based on what you want to do. But remember, color aesthetic information is not for coloring the bars. Okay, let's talk about variations of bar plot. By talking about variations, I'm actually talking about bar plot show the information of two variables. And I think that is very cool because bar plot, the simple bar plot we have been drawing is very simple. And looking at the frequency table, you can get almost the same information. So what if you want to know more about, like, for example, two variables, cut and clarity? And how can you use a bar plot to show both information together? So to do that, let's try to type ggplot data set name, and then we are going to do the geometric bar plot as well. But when we set up the aesthetic information, we are going to use x equals cut, and we are going to change the fill equals to cut, the same variable. And we will use clarity, a second variable in the data set, to draw the graph. So first of all, let us see what does this graph look like. So this is the graph showing us the stacked bars. So you can see each rectangle here is showing one combination of cut and clarity. So if you look at the bottom rectangle here, it means the quality of cut is ideal and the clarity is IF. So same thing if you look at this bar over here, we are actually talking about the quality cut is premium. But according to the color, it shows the clarity, and that clarity is SV2. So each rectangle, each small rectangle is showing us one combination of cut and clarity. Another thing we can do about bar plot with two variables is to use an argument called position. And there are actually 3 positions, but we are going to talk about just 2 of them. And the first position we are going to talk about is called fill, which means you want to add that position into your function and set it up like this. And this position will make each set of stacked bars the same height, and which will also help you to easily compare proportions according to groups. So I'm going to copy the base bar graph, I call it the base bar graph because we are going to make changes to this graph of a few times. So you can see for this bar plot, we have cut variable and we have clarity variable. And one thing I'm going to add is to add a comma after the aesthetic information, and I'm going to add position equals fill. And you can see the graph on the right side, or you can zoom it. So you can see all the bars have the same length to be 100%. And each rectangle now is showing the percentage number of clarity for that specific quality of cut. So again, if you look at the yellow rectangle here, it means it shows us the percentage number for the clarity IF of all the ideal cut diamonds. And this color of rectangle here is showing the clarity of SV2 out of all the ideal cut diamonds. So same thing for all the other rectangles, you are able to see the percentage numbers for each type across the groups. And let's try the other position. Let's name the position dodge. And I'm just going to copy these two lines, and I'm going to copy that dodge to replace the fill. Then it is like this. So the dodge position is easy to help us compare individual values, because you can see here we actually have a bar plot for each quality of cut. We have a bar plot on clarity for all the observations of fair. We have a bar plot for each type of clarity for ideal cut. So you can see exactly which clarity and which type or quality of cut has the most number of observations and which has the least. It is very easy to compare like individual values. Okay, I think we are good on all the bar plot and the variations of bar plot. And let's briefly talk about box plot. I like boxplot a lot because it actually used 5 number summaries of the data. Like if I draw a simple boxplot using ggplot data equals mpg, and then I specify the aesthetic information x equals class, y equals highway miles per gallon, then I can specify the box plot using the geometric objects. And if I run these two lines here, we are seeing a side-by-side bar plot. The side-by-side means we are drawing one bar plot for each class of the car. So this one is two-seater, compact, mid-size, minivan, pickup, subcompact. Like these two values and this value here are outliers, and this one is an outlier comparing with the major box plot, and this one is a large outlier which is above the box plot, and this one is a small outlier which is below the box plot. Also, box plot is helpful showing you the median values for each class of the car. And by doing a side-by-side box plot, you can easily compare the HWY for different class of the cars. So you can see that this one, the mid-size, seems to have the highest median value of HWY. And the pickup seems to have the lowest median value of HWY. And we can also see like these three types, including this type, is having a big difference comparing with pickup and SUV, because they are lower and the other four are actually higher. Or you can consider the mini one on the higher group. Like these box plots are higher and these are lower bars. For box plot, you can also flip the X and Y axis by just doing coord flip and then just run these three lines together. This flipped box plot will be more useful if you have many different types in the X variable. And another thing I want to let you know is that you can actually use different themes to make your graph look more professional or simpler. If I define this graph to be P2 and I run those lines so that P2 is defined, you can see it here, and then I can see this is BW. And if you use another theme, there are many. For example, the classic. And it will look this way. Compare these three graphs by clicking this left arrow to choose like which one will work the best for your presentation, which one will work the best for your report. So this one is the original graph, this one is the BW, and this one is the classic. And you can easily add these different themes to all the graphs that we have been drawing. You can add them by just add a plus sign and then add the theme. The thing I want to talk about is the grammar of ggplot2. I believe by now you have tried many different graphs and you have done many different layers. So you understand that ggplot function, you can add different layers to the ggplot function by specifying the data set, like letting the data equals a specific data set. And then you can add the geometric function, like you can use GEOM, bar. We have talked about bar, boxplot, and scatter plot. So you can specify the geometric objects in here by using GEOM underline the function you want to use. And then you don't forget the plus sign. You can add more information in there by adding like the facet, right? And you can also add something like the flip the graph, so which is called coord flip. And you can even add different themes to the graph, Like you can use BW, Classic, you can even try many different other themes there. These are not real code, so I'm just making them to be a note. And that's it. So if you think back, ggplot2 is so easy to make very professional, very classic graphs. You can make bar plot from it. You can make box plot. You can make scatter plot, or you can make scatter plot with smoothing lines. And you can easily flip the graph to make it fit better, or you can change the facet to put many small pictures in one graph. And you can also add a theme to the picture so that your graph looks very professional, like this one, or even the BW. And that's about it for the chapter 3, data visualization. Thank you.